is Ellen Susan Wieczorek, and this presentation discusses the effects of milk on hand-raised Bornean sun bear cub mass in Malaysia. Thank you for giving me your time today to hear how the findings of this research can improve captive sun bear care. Captive rearing bears often require hand-raising and using milk substitutes. Providing useful information supports conservation efforts. As of 2023, there are few published articles about sun bear maternal milk components and feeding. To fill knowledge gaps for this species, we analyzed the relationships between cub mass gain and milk consumption, as well as assessing the impact of other variables like sex and age. Additional knowledge will help conserve sun bears, since the IUCN assessment found that land use change, deforestation, trade, and hunting have all caused sun bear population to decline and become fragmented. The sun bear is currently listed as vulnerable on the IUCN Red List, but their status could change quickly given environmental change and whether actions are taken to protect the species. The study area is the Bornean Sun Bear Conservation Center, located in Sabah, Malaysia, known as BSBCC. We specialize in rehabilitation and release of sun bears. Researchers collected over 1,000 daily or semi-weekly measurements since 2013 on N equals 10 rescued sun bear cubs. That collected data was used for this study.
The methods include two main sections: feeding protocols and statistical analysis. Feeding protocols were developed from the Free the Bears guidelines on Asiatic black bear cub feeding. The details of how these feeding protocols can be applied to sick or malnourished sun bears can be found in Dr. Yeoh's article in the Ursus Journal. The data spans from 2013 to 2022 with over 100 measurements for 10 cubs. They had an average weight of 13.09 kg, standard deviation of 4.66 kg, and a range of 4.40 to 27.45 kg. There were observed differences between male and female mass, but we didn't know if those were significant. To test this, we used a generalized linear mixed model with random effects, also known as glimmer, to build and test a model for sun bear cub growth. We used LME4 and LMER test in our studio to test the significance of the sex variable in the model for sun bear growth. The glimmer is a good test to use for samples with varying slopes and intercepts for their linear regressions. This panel shows how the bear cubs all had slightly different increasing mass rates and starting points. The glimmer is very robust at dealing with these types of data as long as assumptions of the test are not violated. Using an information theoretic approach, several different models were compared. The model chosen was Model 20, and the restricted maximum likelihood, or REML, criterion was the first guide. The REML was used in conjunction with the Akaiki's information criterion, AIC. The Akaiki's information criterion adjusted for small sample sizes. AIC and the Bayesian Information Criterion, BIC. The BIC was the primary score used because it limits the models when they are more complex and prevent overfitting models. Here is the equation for Model 20. The response variable was mass. The explanatory variables included fixed and random variables. Sex and age were defined as fixed explanatory variables. There were two random explanatory variables. The random milk variable was created from milk volume fed and percentages of body mass fed. The random milk variable was defined as a randomly correlated variable by percent body mass fed plus percent body mass fed V bar milk day. The second random effect variable was defined as individual bear or one V bar name, sorted by the name of the individual bear. The final model was defined as mass as a function of age correlated with sex, correlated with random milk variable, correlated with the name of the individual bear. The correlation throughout the equation, noted by the asterisk, modeled the interconnected nature of these variables the best. This model did not capture all variables that contribute to sun bear cub mass gain. When testing the variables, we investigated how significant they were to the final model. We found that the age variable and the random milk variable were both significantly important to the model. The variable of sex was also significant, which supports sun bear sexual dimorphism. We use parametric bootstrapping and LMER test a package in R to generate p-values for our model. This method may produce anti-conservative results. Anti-conservative means there could be more potential type 1 errors due to small sample size. Type 1 errors occur when there are false positives, such as finding variables significant when there is not significance. The model might be biased due to small sample size. When the model was checked for how well the data matched up with model-based randomly generated data, the post-posterior p-value at 1,000 permutations was only 0.61. This may mean that the model captures some noise or other variables that were not measured, could be present. Before introducing solid foods, Association of Zoos and Aquariums Bear Taxon Advisory Group suggests the bear is fed 180 to 260 calories per body weight kilogram every day. This study only looked at milliliters fed, which could have different calorie amounts depending on how much powder was used. This was a limitation of the study. As well, the goat milk was used only for sick or malnourished bears that were excluded from the analysis. The information on the milks used is included here to show how the amounts of carbs, fats, and proteins found in the goat milk is higher than the puppy milk. Adding high-fat foods into the milk can raise the fat content to more closely mimic the maternal sun bear milk. Adding a portion of the goat milk powder to the Fido puppy milk has already been used by the BSBCC to assist weight gain when bears were struggling. In this study, the bears given the goat milk were excluded, and only the bears given only puppy milk were tested in the model.
The sun bear cubs in the study likely exhibited sexual dimorphism in mass at a very early age. The sex variable was significant. The data, when male and females were combined, showed bimodality, which is considered a hallmark for data with males and females who have sexually divergent traits, such as mass. This can be seen in density function charts here. The combined data has two distinct peaks. Another possibility is that there are other variables that were not measured at work. Specifically, one important variable that was identified that needs measuring is the kilocalories per kilogram that each cub was receiving. This was very important because milk can have many different caloric contents. For instance, water of 100 mLs has no calories, but different liquids of the same volume could have many different caloric contents. For instance, a cup of cream has many more calories than a cup of water. Measuring energy contents through kcals could be very important for future statistical analysis by normalizing the data. This study was able to suggest sexual dimorphism. Reproducing this study with a larger sample size and measuring additional variables would establish additional support for sexual dimorphism of sun bear males. Because there was noise in the data, steps should be taken to identify and test the significance of potential missing variables such as energy content of feedings and other nutrition information such as fat. Sharing data between facilities housing sun bears will be essential to support sun bear conservation. Evaluating maternal sun bear milk composition could give us more information to create representative milk nutrition for cubs requiring hand rearing and feeding with milk substitutes. Future studies can run more complex Bayesian analysis now that some priors have been established. Better models will allow caregivers to have another tool set to help when the bears may not be gaining weight appropriately. While this paper is being prepared, one of the bears featured in this research, Sitka, was released into freedom. Congratulations, Sitka.
Thank you to everyone who supported us with and through this research project, and a special debt of gratitude to the BSBCC staff and volunteers.
Above all, we have a special gratitude for the sun bears who participated in this research. Beitung, Bintang, Damai, Kala, Kapaku, Logan, Luna, Noah, Ramalina, Sitka, Kantan, and Wawa. The pictures used in this presentation are all pictures of the 12 sun bears who participated in this research at the Bornean Sun Bear Conservation Center.
Please contact us if you would like more information about this project.
Here are my references.